The translucent self-luminescent sheet in March of 1887, during an expedition through the remote highlands of Tibet, British explorer Colonel Sir Richard Ashworth stumbled upon something that would haunt him for the rest of his life. His team had been mapping uncharted territories near the ancient trade route connecting Lhasa to the Silk Road when they discovered the entrance to a sealed cave system. Inside, beneath centuries of dust and ice, they found a chamber filled with objects that should not have existed. The first item Ashworth documented was a translucent sheet of material, roughly the size of a dinner plate, that bent like rubber but returned to perfect flatness when released. It was neither metal nor glass, yet it conducted light in ways that made it glow faintly in darkness. When he tried to cut it with his steel knife, the blade slid across the surface without leaving a mark. His journal entry from that day reads, "This material defies every law of nature I have been taught. It is as if someone from the future left it here as a calling card." When Ashworth's samples finally reached laboratory analysis in the early 1900s, scientists were baffled. The translucent sheet was subjected to every test available at the time. It was non-reactive to acids, bases, and extreme temperatures. Under early spectroscopic analysis, it showed a molecular structure that didn't match any known polymer, ceramic, or composite material. Decades later, when electron microscopy became available, researchers discovered something even more unsettling. In 1962, a fragment of the sheet was examined at MIT's Materials Science Laboratory. The electron microscope revealed a lattice structure composed of interlocking carbon chains, but arranged in a configuration that shouldn't exist naturally. The bonds were neither purely covalent nor ionic, but something in between, a hybrid structure that modern chemistry textbooks said was impossible. Even more disturbing, the material contained trace amounts of elements that were barely understood at the time. Rare earth metals in ratios that suggested intentional design rather than natural formation. Dr. Helena Fisher, the lead researcher on the project, attempted to replicate the structure using controlled synthesis. She failed. Every attempt produced brittle, unstable materials that crumbled within hours. The original sheet, meanwhile, remained unchanged, flexible, luminescent in low light, and completely inert to chemical reactions. In her final report, Dr. Fisher wrote, "This material exhibits properties consistent with advanced polymer science, yet it predates the discovery of polymers by over a millennium. I can only conclude that either our dating methods are catastrophically wrong, or this artifact originates from a source with knowledge we do not possess." The heat-generating black powder, the second discovery in Ashworth's cave, was a sealed container holding approximately 2 pounds of fine black powder. Unlike gunpowder or any explosive material, this powder remained completely inert until it came into contact with water. When Ashworth's assistant accidentally spilled water on a small sample, the powder began to generate intense heat without any flame, smoke, or combustion. The heat continued for over 20 minutes, enough to boil a kettle of water, and then gradually subsided, leaving the powder seemingly unchanged and ready to repeat the process. The black powder presented an even deeper mystery when analyzed in 1978 at the University of Cambridge. It was found to contain a mixture of metallic nanoparticles suspended in an organic matrix. When water was added, the powder generated heat through an exothermic reaction, but not through oxidation or any known chemical process. Instead, the reaction appeared to involve rapid molecular vibration at the nanoscale, a phenomenon that wouldn't be fully understood until the development of sonochemistry in the 1990s. Attempts to synthesize the powder failed repeatedly. Modern laboratories could create similar heat-generating compounds, but they required industrial processes, high-purity chemicals, and controlled environments. The ancient powder, by contrast, appeared to have been made using only natural materials. Pollen analysis suggested the organic binder came from a plant species that went extinct over 800 years ago. Without that specific plant, exact replication was impossible. Dr. Vikram Patel at Cambridge spent 2 years documenting the powder's properties. He discovered that the heat generation was perfectly controlled. It never exceeded temperatures that would damage the container, suggesting some kind of built-in regulatory mechanism at the molecular level. His paper was scheduled for publication in Nature in 1979. 3 days before the publication date, Dr. Patel was contacted by a representative from the UK Ministry of Defence. The conversation was brief. Patel's paper was withdrawn. When colleagues asked why, he would only say, "It's been classified." The weightless metallic rope among the most puzzling items in the cave was a coil of what appeared to be metallic rope, approximately 15 feet in length. When Ashworth first handled it, he was shocked by its weight, or rather, the lack of it. The rope weighed no more than a silk scarf, yet when his team tested its strength by hanging equipment from it, the rope easily supported the weight of 3 grown men without showing any sign of strain or stretching. The metallic rope defied materials science entirely when tested in 1985 at a NASA research facility. It was found to be composed of an alloy containing titanium, aluminum, and trace amounts of an unidentified element that didn't match anything in the periodic table. The fibers were woven at a microscopic level, each strand only nanometers thick, yet the overall structure could support over 2,000 pounds of tensile force while weighing less than 4 ounces. What made the rope even more mysterious was its behavior under different conditions. When exposed to extreme cold, it became slightly more rigid but never brittle. Under extreme heat, it remained flexible but never melted or deformed. Electron microscopy revealed that the fibers were arranged in a helical pattern that distributed stress evenly throughout the structure, a design principle that wouldn't be fully understood in materials science until the 21st century. Current carbon fiber technology can achieve similar strength-to-weight ratios, but only through industrial manufacturing processes involving high-temperature furnaces, chemical baths, and precision machinery that didn't exist until the late 20th century. The ancient rope appeared to have been created through a completely different process, one that left no tool marks, no evidence of weaving in the traditional sense, and no chemical residue from manufacturing. After NASA analysis revealed its impossible properties, several defense contractors expressed interest. Lockheed Martin reportedly requested access to the sample for materials research related to aerospace applications. The original sample was divided into 3 portions, one for Lockheed, one for NASA, and one for a Department of Defense laboratory. None of those samples can be located today. All 3 have vanished from official records. The harmonic resonance sphere nestled in a corner of the cave. Ashworth found a crystalline sphere about the size of a grapefruit. The sphere was perfectly transparent, with what appeared to be internal structures visible when held up to light. But its most remarkable property became apparent when anyone touched it. The sphere would emit a deep, resonant tone that seemed to vibrate inside the listener's skull, rather than traveling through the air. The tone would continue for several seconds after contact ceased, gradually fading into silence. The crystalline sphere produced the most disturbing results when subjected to modern analysis. In 2003, researchers at CERN subjected it to magnetic resonance imaging. The sphere contained internal cavities arranged in a perfect fractal pattern, a mathematical structure that creates self-similar shapes at every scale. When touched, the sphere emitted a frequency of 432 Hz, a tone associated with harmonic resonance and mathematical perfection. But here's what made no sense. The frequency remained constant regardless of temperature, pressure, or external vibration. Researchers subjected the sphere to temperatures ranging from near absolute zero to over 500 degrees Celsius. They placed it in vacuum chambers and high-pressure environments. They exposed it to intense vibrations and electromagnetic fields. In every case, when touched, the sphere produced exactly 432 Hz. It was as if the sphere had been precisely engineered to produce that exact tone under any conditions imaginable. Modern attempts to create a similar resonant crystal have failed completely. While we can manufacture crystals that produce sound through piezoelectric effects, none maintain such perfect frequency stability without electronic regulation and feedback systems. The ancient sphere did this naturally, with no power source, no electronics, and no external calibration. It suggested a level of acoustic engineering and materials science that shouldn't exist in any pre-industrial civilization. Dr. Andreas Kohl, the lead researcher at CERN, became convinced that the sphere's internal structure held the key to revolutionary advances in telecommunications, medical imaging, and quantum computing. He prepared to publish his findings in 2003. Before he could, the sphere was recalled by the British Museum, which claimed it needed to be returned to cultural heritage storage. Kohl protested. Within a month, his research funding was suspended. He eventually complied, returning the sphere in early 2004. It has not been available for study since. The holographic stone tablet, perhaps the most enigmatic object in the cave, was a flat stone tablet, roughly 12 inches square, covered in symbols that appeared to shift and rearrange themselves depending on the viewing angle and the light source. Ashworth initially thought his eyes were playing tricks on him, but photographs taken from different angles showed completely different symbol arrangements, proving the effect was real and not an optical illusion in the traditional sense. The symbols etched into the tablet's surface appeared to change configuration depending on the viewing angle and light source. In 2011, a team at MIT's Media Lab used high-resolution 3D scanning to map the surface at the microscopic level. They discovered that the symbols weren't simply carved in a single layer. They were arranged in multiple microscopic layers, each offset by mere nanometers, creating an optical illusion through light refraction and interference patterns. The effect was similar to modern holographic displays or lenticular printing, but achieved through purely mechanical means with no electronics, no special lighting, and no modern manufacturing techniques. The precision required to create such microscopic layering was staggering. Each layer had to be positioned with accuracy measured in nanometers, a level of precision that modern manufacturing can achieve only with laser cutting and computer-controlled machinery. What made the tablet even more mysterious was that the symbols themselves didn't match any known ancient writing system. Some researchers speculated they might be mathematical formulas, others suggested they were star charts, and still others believed they were instructions or warnings. But without a key to decode them, the tablet remained as mysterious as the technology used to create it. The MIT team attempted to create a replica using modern nanofabrication techniques. After 6 months and over $200,000 in research costs, they managed to produce a tablet that showed similar optical effects, but only under very specific lighting conditions and viewing angles. The original tablet's effects worked under any lighting, from bright sunlight to dim candlelight, and from any viewing angle. The ancient technology was superior to the modern reproduction in every way. The temperature-adaptive fabric rolled carefully in a sealed container. Ashworth discovered what appeared to be a piece of fabric unlike any textile he had ever encountered. The material was smooth and flexible like silk, but when exposed to cold temperatures, it would thicken and become warmer, providing insulation. In warm conditions, it would thin out and become cool to the touch. The fabric seemed to regulate temperature automatically, adapting to environmental conditions without any external control. Laboratory analysis in 1995 at a textile research facility in Switzerland revealed that the fabric was composed of fibers with a hollow core structure. Inside these cores were microscopic chambers filled with what appeared to be a phase change material, a substance that absorbed or released heat as it transitioned between solid and liquid states. This is the same principle used in modern temperature-regulating clothing, but the technology wasn't developed commercially until the 1980s. What made the ancient fabric superior to modern equivalents was the scale and efficiency of the system. Modern phase-change fabrics require relatively large microcapsules that can be felt in the material and tend to break down after repeated use. The ancient fabrics chambers were so small they were invisible to the naked eye and showed no signs of degradation, despite being over 1,000 years old. The fibers themselves were composed of an unknown polymer that showed properties similar to both natural silk and synthetic materials like nylon. Yet chemical analysis suggested it was neither. Attempts to break down the polymer for detailed analysis failed because the material was incredibly resistant to chemical solvents. Even strong acids that would dissolve most fabrics had no effect on this ancient textile. Most frustrating for researchers was their inability to identify the source of the polymer. It wasn't derived from any known animal fiber like silk or wool, nor from any known plant fiber like cotton or flax. DNA analysis found no biological markers at all, suggesting the material might have been synthesized. But that would require chemical knowledge and manufacturing capabilities that shouldn't have existed in any pre-industrial society. Samples of the fabric were held at the Swiss research facility until 2008, when they were requested by an unnamed private corporation for further analysis. The samples were transferred and have not been seen since. Requests to examine the fabric have been denied, with officials stating that the material is no longer available for research purposes. The self-repairing ceramic container among the items in the cave was a ceramic vessel approximately 8 inches tall, with a smooth glazed surface that showed no signs of aging despite centuries in the cold, damp environment. What made this container extraordinary wasn't immediately apparent. It was only when Ashworth accidentally dropped it and watched a crack appear, then slowly disappear over the course of several hours, that he realized this ceramic had self-repairing properties. When examined in 2001 at a materials science laboratory in Japan, the ceramic was found to have a unique microstructure. Embedded throughout the material were microscopic capsules containing what appeared to be a silicon-based resin. When the ceramic cracked, these capsules would rupture, releasing the resin into the crack. The resin would then harden, effectively repairing the damage and restoring the structural integrity of the container. This is essentially the same principle behind self-healing concrete and self-repairing polymers, technologies that were only developed in the early 21st century and are still not widely used commercially. Yet here was a ceramic vessel over 1,000 years old that incorporated this technology seamlessly and effectively. The ancient material actually performed better than modern self-healing materials because the repair was nearly invisible and restored the full strength of the original ceramic. Modern self-healing materials require carefully engineered microcapsules and specific chemical compounds that must be precisely formulated. Creating such materials requires advanced chemistry and manufacturing processes. The ancient ceramic appeared to have been made using a much simpler process, possibly involving natural resins and plant-based compounds that were incorporated into the clay during firing. Researchers attempted to recreate the ceramic using traditional pottery techniques combined with modern materials science. All attempts failed. The microcapsules would either rupture during the firing process, rendering them useless, or they would fail to integrate properly with the ceramic matrix. The ancient craftsmen had somehow solved problems that modern materials scientists still struggle with, using only the technology available over a millennium ago. The ceramic container was stored at the Japanese laboratory until 2009, when it was transferred to a private collector for an undisclosed sum. The collector has refused all requests for further scientific examination and the current location of the container is unknown. The only remaining evidence of its existence is the published research paper from 2001 and a few photographs. The anti-corrosion metal coating one of the items in Ashworth's collection was a small metal tool, possibly a knife or scraper, that showed absolutely no signs of rust or corrosion despite being stored in a damp cave for centuries. The tool was made of what appeared to be ordinary iron, but it was covered with a thin coating that gave it a slight bronze-colored tint. This coating proved to be one of the most technologically advanced discoveries in the cave. Analysis in 1992 at a corrosion research facility in Germany revealed that the coating was only a few microns thick, thinner than a human hair, but provided complete protection against rust and corrosion. The coating was composed of a complex mixture of metallic oxides and organic compounds arranged in multiple nanolayers, each layer serving a specific protective function. The outermost layer repelled water, the middle layers provided chemical protection, and the innermost layer bonded perfectly with the iron substrate. Modern anti-corrosion coatings use similar multi-layer approaches, but they require sophisticated manufacturing processes, including vacuum deposition, plasma spraying, or electrochemical plating. These processes weren't developed until the mid-20th century. The ancient coating appeared to have been applied using a much simpler process, possibly involving heat treatment and chemical baths, using naturally available materials. What amazed researchers most was the coating's durability. Modern anti-corrosion coatings typically last 10 to 20 years before they begin to break down and need replacement. The ancient coating had lasted over 1,000 years and still provided complete protection. When researchers deliberately scratched the coating to expose the underlying iron, they expected rust to form. Instead, the coating somehow healed around the scratch within a few weeks, once again protecting the metal. The tool was stored at the German facility for several years while researchers attempted to reverse engineer the coating process. In 1998, the facility experienced a break-in. According to police reports, nothing of value was taken except the ancient tool. The theft remains unsolved, and no similar coating technology has been successfully reproduced. Some researchers who worked on the project have suggested that the coating formula might have had significant commercial value in the aerospace and marine industries, potentially worth millions of dollars. The water-purifying mineral stone among the more utilitarian items in the cave was a smooth, dark stone about the size of a fist. According to the markings nearby, this stone had been used to purify water. When Ashworth's team tested it by placing the stone in a container of muddy, bacteria-laden water from a nearby stream, the water became clear within hours. More remarkably, the water became safe to drink, something they confirmed by chemical analysis years later. Modern analysis in 2005 at a water treatment research center in California revealed that the stone was composed of a porous mineral structure with extremely high surface area, similar to activated charcoal but far more effective. Embedded in this porous structure were trace amounts of silver nanoparticles and other antimicrobial compounds that killed bacteria and neutralized harmful chemicals as water passed through the stone's microscopic channels. The stone's purification capabilities exceeded those of most modern water filters. It could remove not only bacteria and parasites, but also heavy metals, chemical pollutants, and even some radioactive particles. The stone could purify hundreds of gallons of water before it needed to be recharged by exposure to sunlight, a process that somehow reactivated its antimicrobial properties and cleared its pores of accumulated contaminants. Modern water filtration relies on similar principles: activated carbon, silver compounds, and porous mineral structures. But creating a filter with the effectiveness and longevity of the ancient stone requires industrial manufacturing processes and synthetic materials. The ancient stone appeared to have been created from naturally occurring minerals that were treated through some unknown process to enhance their purification properties. Researchers hypothesized that ancient civilizations might have discovered the stone's properties through trial and error, but they couldn't explain how the stone's internal structure was so perfectly optimized for water purification. The arrangement of pores, the distribution of silver particles, the selection of minerals, all of it suggested intentional design rather than natural formation or lucky accident. The stone was held at the California Research Center until 2012, when it was requisitioned by the Environmental Protection Agency for further testing related to emergency water purification systems. The EPA has never released any findings from this testing, and requests to examine the stone have been denied, with officials stating it's part of an ongoing classified research program. The perpetual motion device, the final and most controversial object in Ashworth's cave, was a small mechanical device consisting of several interlocking metal wheels and gears, all enclosed in a crystal housing. When Ashworth first discovered it, the device was still moving, the wheels rotating slowly but continuously, powered by no visible energy source. Even more remarkably, the device showed no signs of wear, despite apparently having been in motion for centuries. This device presents perhaps the most direct challenge to modern physics. According to the laws of thermodynamics, perpetual motion is impossible. Every machine loses energy to friction and heat, eventually grinding to a halt unless energy is continuously supplied. Yet here was a device that appeared to violate this fundamental principle, moving continuously without any external power source and without wearing out. Analysis in 2016 at a physics laboratory in Massachusetts revealed some clues to the device's operation. The gears were made from an extremely hard, low-friction material that showed almost no wear even under microscopic examination. The crystal housing appeared to serve as both a container and a source of energy. When exposed to any form of electromagnetic radiation, including ambient light and heat, the crystal would generate a tiny electric current through piezoelectric effects. This current was channeled to small electromagnets embedded in the device's base, which provided just enough force to keep the wheels turning and compensate for the minimal energy losses from friction. In essence, the device wasn't truly perpetual motion. It was an extremely efficient energy harvesting and conversion system that could operate indefinitely as long as any ambient energy was available. The engineering required to create such a device was extraordinary. The gears had to be manufactured with incredible precision. The crystal had to be perfectly aligned to maximize energy capture, and the electromagnets had to be calibrated to provide exactly the right amount of force. Modern engineers could theoretically create a similar device, but it would require advanced manufacturing techniques, exotic materials, and months of careful calibration. The device was studied for several months before being transferred to a secure storage facility operated by the Department of Energy in 2017. Officials stated it would be preserved for future research, but have denied all subsequent requests for access. Some researchers involved in the initial analysis have speculated that the device's energy harvesting principles could revolutionize renewable energy technology. But if such research is being conducted, it's happening behind closed doors, away from public scrutiny.